exercise 1.4 chapter 1, that's real numbers. What's the first question? We'll see. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal or a non-terminating repeating decimal expansion. So first there are totally 10 in this. The first one with the solution we'll be doing. So solution for this, the first one is 13 by 3125. So how do we write this? It's equal to 13 by 3125. When you find the LCM, you will get it as 5 to the power of 5, which is equal to 13 into 2 to the power of 5. What we are doing here is we have to make the denominator here. It should be terminating, means the denominator should consist multiples of both 5 and 10. So therefore you will get here 2 to the power of 5 into 5 to the power of 5. Because you are already having this, we are multiplying and dividing by 2 to the power of 5. If you want, I'll show you in this one. 3125. You can see here 3125. If you take the LCM, 5 6 are 30, 5 2s are 10, 5 5s are, 5 1s are, 5 2s are 10, 5 5s are, 5 2s are 10, 5 5s are, 5 5s are. So you are getting it as equal to 5 to the power of 5. So therefore this you can write it in this. Now we have to make the denominator as a multiple of 10, because it is should be a terminating decimal. Whether we have to show it as a terminating or non-terminating decimal. So we'll show it in this way, which implies that (13 by 3125) has a terminating decimal expansion, because it can be written in the form of 2 to the power of 5 into 5 to the power of 5, which can be written as 2 into 5 whole to the power of 5. So this is nothing but 10 to the power of 5. Anything to the power of 10 in the denominator, it becomes a terminating decimal. Okay, second one. What's the second problem? We'll see. Second one is 17 by 8. 17 by 8 can be written as 17 by 2 cubed. You only can see 2 into 2 into 2 will give you 8. So which implies that this also is a terminating decimal, because you can write the denominator. You can multiply it by 5 cubed in the numerator and denominator. So therefore you will get here 17 by 17 into 5 cubed divided by 2 into 5 whole to the power of 3, which is a terminating decimal. He is just asking to write whether it is a terminating or non-terminating. In the next problem, second one, we have to expand it anyhow. That time I'll be writing all those. Has a terminating decimal. What is the actual value? We'll be writing down. Terminating decimal expansion. Now the third one, or the third problem, we'll see. 64 by 455, it is equal to 64 by 455. When you are taking the LCM, you have first 5 9s are 45 and 5 1s are, then you can take it as 7 1s are, 7 3s are, So 13 ones. So you can write the denominator as 5 into 7 into 13, because the denominator does not have multiples of 2 or 5, either 2 or either 5, or multiples of both 2 into 5. Therefore it is not a terminating. Therefore, since in the denominator we have multiples of 5, 7 and 13, 64 by 455 has a non-terminating repeating decimal. Terminating repeating decimal. So you can clearly see that in the denominator we have only multiples of 5, 7 and 13. We don't have multiples of 2. So therefore it should be multiple of 2 and 5 only. Other than 2, it can be either 2 or either 5 or both combination, that is 2 into 5. It cannot be 7 or 13 or any other odd numbers. So therefore this has a non-terminating repeating decimal expansion. Next, fourth one, 15 by 1600 is equal to 15 divided by 1600. The factors of 1600 are 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 100s are, then you're having 2 50s are, 2 25s are, 5 5s are. So how many 2's we have? 1 2 3 4 5 6. So 2 to the power of 6 into 5 to the power of 2. So which implies, because you're having in the denominator, you can write this as 15 by 2 to the power of 6 into 5 to the power of 2. You can multiply it with 5 to the power of 4 into 5 to the power of 4, which is equal to 15 into 5 to the power of 4 by 2 to the power of 6 into 5 to the power of 6. So this implies that 15 by 1600, because we can write the denominator in the form of 2 into multiple of 2 into 5. So therefore has a terminating decimal expansion. Next, fifth one, this we have 29 by 343, which is equal to 29 by 343 can be written as, if it is divided by LCM of this is 7. Okay, if we take 7, 7 4s are 28, 7 9s are 63, 7 7s are, so 7 1s are getting 7 cubed over here. So which implies that 29 by 343, because in the denominator you don't have a multiple of 2 or 5, you have 29 by 343 has a non-terminating decimal expansion. Sixth one, 23 by 2 to the power of 3 into 5 square. So now here in the denominator you are having a multiple of 2 and 5. So definitely this can be written as 23 by 2 cubed into 5 square. You can multiply and divide by 5. So you get the 23 into 5 divided by 2 cubed into 5 cubed. So therefore it has a terminating decimal expansion. 2 cubed into 5 square has a terminating decimal expansion. The next problem, seventh one, 129 divided by 2 square into 5 to the power of 7 into 7 to the power of 5. Since the denominator has a multiple of 2, 5 and 7, it has a non-terminating repeating decimal expansion. Next, eighth. 6 by 15 is equal to 6 by 3 into 5, which is written as, you can write the numerator as 2 into 3 by 3 into 5. So 3 will get cancelled. So it is written as 2 by 5. Since the new denominator is a multiple of 5, it can be multiplied with 2 and in the numerator and denominator. So you're going to get it as 4 by 10. Since the denominator is a multiple of 10 or a multiple of 2 and 5, so therefore it is a terminating decimal expansion. It has a terminating decimal expansion. Next, ninth one. 35 by 50 can be written as 35 by 2 into, you can 5 square, because 25 into 2 is 50. So therefore this can be written as 35 into 2 by 2 square into 5 square. So therefore this is 70 by, it is a multiple of 2 and 5. So the 2 into 5, that is you're getting 10 in the denominator. So it has a terminating decimal expansion. Next, 10th one. 77 divided by 210 is equal to 77 divided by, now what is the LCM of 210? We'll see. You go into 2, 2 ones are, 2 zeros are, 2 fives are, then you have to go into 5, 5 twos are, 5 ones are, then 3 sevens are, 7 ones are. So you're having in the denominator multiple of 2 into 3 into 5 into 7. Since it is not a multiple of 2 into 5, it has 3 and 7 also. It's a multiple of 3 and 7. Therefore, it has a non-terminating. It has a non-terminating decimal expansion. Non-terminating repeating decimal expansion. So then we'll go into the next question 2. What second question we'll see. Write down the decimal expansion of those rational numbers in question 1 which have terminating decimal expansions. Solution. So we are having how many terminating decimals? We'll just see. The first one was terminating. So the first one, 13 by 3125 is equal to 13 by 5 to the power of 5. So what is the terminating? We have to write down that in the form, in the decimal expansion of this. So which is equal to 13 into 2 to the power of 5 by 2 to the power of 5 into 5 to the power of 5, which is equal to 13 into 2 to the power of 5 divided by 2 into 5 to the power of 5, which is equal to 13 into 2 to the power of 5 divided by 10 to the power of 5, which is equal to 416 divided by 10 to the power of 5, which is equal to 0.00416. This is the answer. So second one, which is a decimal expansion, which is a terminating decimal expansion. We'll see 17 by 8. The second one is also there, which is equal to 17 by 2 cubed, which can be written as 17 into 5 cubed by 2 cubed into 5 cubed, which is equal to 17 into 5 cubed divided by 2 into 5 whole cubed, which is equal to 17 into 5 into 5 into 5 divided by 10 cube, which is equal to 2125 divided by 10 cube, which is equal to 2.125. So next, third one is, the fourth one is a terminating decimal. So we can write 15 by 1600 is equal to 15 by 2 to the power of 6 into 5 square we got. So which is equal to, we have to multiply and divide by 5 to the power of 4 to make the power same. So therefore 2 to the power of 6 into 5 to the power 5 square into 5 to the power of 4, which is equal to 15 into 5 to the power of 4 divided by 2 to the power of 6 into 5 to the power of 6, which is equal to 15 into 5 into 5 into 5 into 5, that is 15 into 625 divided by 2 into 5 to the power of 6, which is equal to 9375 divided by 10 to the power of 6, which is equal to 0.009375. Next, 23 by 2 to the power of 3 into 5 square, which is equal to 23 into 5 divided by 2 to the power of 3 into 5 to the power of 3, because we have to make the denominators as factors of 2 and 5. So here you are going to multiply, the powers should be the same. So we are multiplying by 5 in the numerator and denominator 5. So therefore you are going to get this as 115 divided by 10 whole cubed, which is equal to 0.115. Then the eighth one, 6 by 15 can be written as 2 into 3 divided by 3 into 5. So this is equal to 2 by 5. Since it is a factor of only 5 or only 2 or a factor of both 2 and 5, then only it is terminating decimal. So therefore this can be written as 2 into 2 by 2 into 5, since you have to bring the denominator as a multiple of 10. So this is equal to 4 by 10. So you are getting it's equal to 0.4, which is a terminating decimal. Then next, we are having the ninth one is also a decimal expansion. So ninth one is 35 by 50, which can be written as 35 by 2 into 5 into 5, that is 5 square you are getting. So 35 by 2 into 5 square, if you multiply with the 2 in the numerator and in the denominator, you will get it as 70 by 2 square into 5 square, which is equal to 70 by 2 into 5 whole square, so which is equal to 0.70. Numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? The first question given is 43.12345678 So how many numbers we are having after the decimal? 3 4 5 6 7 8 9. So we can write first one, 43.12345678 Now this is a terminating decimal expansion. You can see clearly because it has ended over here. So you can tell that it has a terminating decimal expansion. It is a rational number in the form rational number in the form of p by q, and q has factors of 2 and 5 only. Next, second one, 0.120, 1200, 123 zeros, 1 2 followed by 4 zeros, so on. Clearly you can see that since it has non-repeating and non-terminating decimal expansion, non-terminating and non-repeating decimal expansion, it is an irrational number. Third one, 43.123 5 6 7 8 9. This has a non-terminating and repeating decimal. Since it has a non-terminating but repeating decimal expansion, it is also a rational number. It is a rational number in the form of P by Q, and Q has factors other than 2 and 5. Next, going to the next problem, the fourth one, 123.096. So clearly it is a rational number. It's a rational number and it has a terminating decimal expansion, and is in the form of P by Q, and Q has factors of 2 and 5 only, or Q is of the form 2 to the power of n into 5 to the power of n. Next, fifth one, 21.23478. So you can see that it has a non-terminating repeating decimal expansion, and can be expressed in the form of P by Q, which is a rational number where the factors of Q are other than 2 and 5.